Hello everybody and welcome back to this course. In this video, we're going to create the first script of this game, which will make our player character move left or right when he presses the left or right arrow keys on the keyboards. Let's start off by creating a folder called scripts. So I'll go down to the assets window, I'll right click on it, and I'll choose create folder. Then I'll name it scripts. We will store all our scripts in this folder just to keep things nice and organized. Let's now open up that folder and we will now create our first script. So right click and go to create C# scripts. I'll call it player because this script is going to be for our player character, but you can call it whatever you want, it doesn't matter. Let's now drag and drop this C# script onto our player in the hierarchy. If you now select the player, you should see that he has the player script attached on him. We are also going to add another component to the player which is called the rigid body 2D. This component will give us access to all the physics engine of Unity, and to move our player we'll be using physics. There are a bunch of settings that you can tweak on this component, but for now we will just set the gravity scale to 0 because we don't want our character to be affected by gravity in this game. Let's now double click on the player script to start coding it out in our text editor. Okay, so the very first step to make our player move right or left is to detect and to store the input of the player. We basically want to know if the player is pressing down the right or left keys. We want to check if they are pressing down the arrow keys very often, so we will go inside of the update function, which I remind you runs anywhere between 30 and 60 times every second. But because we're going to be using physics, we're actually going to use the fixed update function instead of just the update function. So just add fixed in front of the update words. The only thing that you have to know is that whenever we are working with physics, you have to use the fixed update function instead of the regular update function. To store the input of the player, we are going to create a float variable called input. We are creating a float variable because this variable is going to be equal to a number between -1 and 1. If neither the left or right arrow keys are being pressed, this variable should be equal to 0. If the left key is being pressed, it should be equal to -1, and if the right key is being pressed, you guessed it, it should be equal to 1. The way that we will achieve this is by setting the variable to be equal to input.getAxis, and inside of the parentheses we'll type in the string horizontal. Make sure that you put a capital H on the word horizontal. Let's now just print out to the Unity console the value of our input variable so we can see how this variable is going to work. So let's save our script by pressing Ctrl S or Command S if you're on the Mac, and let's head over back to Unity. Let's now press the play button and let's also open up the Unity console. You'll see that if you don't press any keys, the value of the input variable is equal to 0. If we now start pressing the left arrow key, the value turns to -1, and if we press the right arrow key, the value turns to 1. As you can see, there is some smoothing between the values. We are not jumping from 0 to -1 or from 0 to 1. The value of the input variable is transitioning from one value to another. This will give a smooth feeling to the movement of the player. If you would like a more snappy, responsive movement, we can go back to our script and change getAxis to getAxis raw. This will now remove any smoothing. We usually prefer getAxis raw for a more responsive feeling, which is better for a reflex-based game like the one we are creating in this project. Now that we know the input of the player, the second step is to actually move the player. To do so, I'll start off by creating a variable of type rigid body 2D that I will call RB for short. So for now in this course we have learned about string, float, int and bool variables, but in Unity we can actually make variables of the same type as components. So that's why we're creating a rigid body 2D variable, which is the components that we added to the player to enable us to use physics. We now have to set this RB variable to be equal to the rigid body 2D component that is attached to the player character. To do so, I'll go inside of the start function, I will set the RB variable to be equal to getComponents, and inside of the edge brackets we will specify what component we are looking for, and so in this case it will be rigid body 2D. Okay, so we now have the RB variable, which is basically storing the rigid body 2D component that is attached to the player character. We are also going to create a public float variable called speed, which will enable us to tweak how fast or slow the player can move inside of our game. We're making it public so that we can easily modify the speed variable inside of the inspector. We now have to write one last line to actually move our player. Let's go inside of the fixed update function. To make the player move, we'll modify the velocity of our RB variable. A velocity dictates how fast an object moves in a certain direction. This RB.velocity variable is a variable of type vector2. A vector2 variable is basically a x and y coordinates. In other words, it's a variable that stores a pair of two floats. The x-axis represents the movement on the right and left, and the y-axis represents the movement on the top and bottom. So we'll set rb.velocity to be equal to a new vector2. Inside of the parentheses, we have to set the x and y coordinates. Because we want our player to move right or left, that corresponds to the x-axis. And so for the x-axis, we'll type in inputs times speeds. And for the y-axis, we don't want to change it, so we'll just set it equal to rb.velocity.y. Okay, so let's now save our script and let's head over back to Unity. Before we press play and test this out, let's choose a speed value for the player. I'll choose 10, but feel free to play around with this value. If we now press the play button and start pressing down the arrow keys, you can see the player is moving perfectly. So let me quickly recap the script that we just created. We first of all created a float variable that stores a number between -1 and 1 depending on what arrow keys the player is pressing. Then we created a rigid body 2D variable that stores the rigid body 2D component that is attached to the player character. We then use that RB variable by modifying the velocity of it. The velocity is a vector2 variable, which means a x and y coordinate, and because we want to move right or left, that corresponds to the x-axis. We are setting it equal to input times speed, and the y coordinate does not need to change, so we're just setting it equal to its current value, which means rb.velocity.y. Anyways guys, it's really important that you know that if you're having trouble understanding how the script works, that's okay, and it's even normal. When me and my brother started creating games, we hardly understood what was going on. It will take time to understand, so keep at it guys. One day it will all make sense, so just copy along and let's just create a game and have fun. Don't worry too much if you don't get everything. For now the player can move right or left, but he can move too much to the side and get off screen, and we don't really want that. To fix this, we're going to create invisible walls. So I'm going to right click in the hierarchy and I'm going to create an empty game object. This is just a game object that doesn't have any graphics. I'll then add a component called Box Collider 2D. This component is basically an invisible wall that will enable us to detect collisions and block the player. So if I now press this button, we can actually shape the invisible wall as we like. So just make it long enough so that it covers the entire edge of the game. Then we're going to press Ctrl D or Command D if you're on the Mac to duplicate it, and we'll move the new one onto the other side. We also need to add a Box Collider 2D to the player. So I'll add that component and I'll shape it so that it fits the player nicely. If we now press the play button, you'll see that indeed the invisible walls are working perfectly and we are detecting collisions between the player and the invisible walls. Okay, this marks the end of this video. We have gotten our player moving right and left and he's getting blocked by some invisible walls. And remember guys, if you feel a little bit lost and unsure of how all this is working, it's completely normal. Just keep at it guys. Anyways, I'll see you soon. Cheers.